Hello everyone, welcome back to another video in the LLMs related playlist. In this video, we are going to see how I made my current best model till date, where in open source LLM leaderboard, I have uploaded probably one of the top 50 models, that too just using Google Colab. That is what we are going to see today. So let's jump into the video right now. As you can see here, under my name Vasant, there is a new model known as Beast Soul New, which is open sourced, even you guys can use, and it has scored around 75%, which is not that bad. Probably it is around, like I said, a top 50 model, and thanks to Mergekit. A huge shout out to the creator Charles Goddard, and recently this project has been merged with RCAI, and this is a pretty good project. It was an individual project, but it is now combined with RCAI, and that is how I created my current best model, and the model is giving pretty good results. So if you want to play around with his merge kit, he has given a notebook also, but I have also given a notebook. The best I can create right now. I didn't take a lot of effort for this because it didn't cost me a lot of computation. I just use Google Colab, okay, and for Google Colab free, so it is available for you guys to use as well. So before going on to the implementation part, let me say you what this merge kit is all about. The thing which has been trending, or the concept which has been trending recently, is about model merging. The base idea is that there is a common architecture which has been followed around the industry, probably a revolutionary model like Mistral or Phi 2 or even Llama 2 for the matter. And there are a lot of fine-tuned variants available over the internet. The idea of merging is that you will merge two or more models so that the knowledge is shared. Let me give you an example. For example, I have a model A, a model B, and a model C. Okay, A is a model which is very good with poetry, B is a model which is very good with mathematics, and C is a model which is very good with probably comprehension and QA, like that. So if I combine all of these models into a single model, right? The first thing is, in place of three models, you are having one model. That is pretty good. And the second thing is, you are having one model which has all the capabilities. All right, that is pretty good. And that is how I created this Beast Soul New, and I'll walk you through what is there and what you should do. But before going on to that, let me walk you through this blog written by Maxim Labone, and huge shout out to him as well, and because this is the best blog which is there out in internet for merging models. So there are four main methods for merging model, with the first being slurp. All right, slurp is known as spherical linear interpolation, and it is used to smoothly interpolate between two vectors. Okay, I'll put to you in an easy way. Okay, this is a traditional method where, let's say you have a vector. Okay, let's say there is two vectors actually, because there are two models, and given a layer you have two vectors, and the idea is that the vectors are in a 3D plane and you want to make those two vectors into a single vector. Okay, so the first thing is they would normalize the input vectors. So what happens with normalization is that usually you will have all of those in a single range, right? Like it is 0 to 1. So even if the vectors are negative, one is negative and other is positive, the first thing is you are getting rid of the direction and you are holding on to the magnitude alone. That is the first point. Second thing is, since these are vectors, there is an angle between them, and you're going to find that with the help of dot product. And once you find that, okay, this vector are nearly collinear, it doesn't matter. Like, you can do normal linear interpolation, and if it doesn't, then you will have a scaling factor or interpolation factor, so that you will try to get the angle and merge all of those into a single one. That is how these vectors are combined together. This is a pretty famous method, and the author has said that this is the most popular merging method, and I have used this method as well. Okay, don't worry about the configuration, let me say about that later. Alright, the one thing which is a disadvantage in Slurp is that you can only merge 2 models at a time. Okay, let's say I have 5 models to merge and 5 different tasks probably. You can't merge all of those 5 at a single time, which you can do with ties. Ties is the second paper, or the second method which has come as a paper. Okay, this is a pretty good paper, a pretty good read if you will. I would recommend you all to go through this paper, but if you think, okay, I'm not having time, so Vasant, can you make a video? Please let me know in the comment section. I'll make a video on ties merging itself for sure. But overall, this is the idea of ties. So what happens is, let's say I have 3 models here, right? Model 1 is purple, model 2 is pink, and model 3 is yellow. Let me put it as yellow. Okay, at each task, right? So what they would do is, model state dict is there, right? Usually we have our model state dict, and that will be converted as normal vectors. Okay, there is a function in Torch to convert state dict into vectors, and at a given neuron, whichever vector constitutes less information for a given task, it will be removed. Okay, so for example, before trim, here you can see, right, the pink one is very large, I mean like very high, and the other 2 are very less. And the other thing is, like, the yellow is high, the other 2 are low. In this, the pink is also good, violet is also good, but the brown is not good, or yellow is not good. So similarly, what you will do is, wherever this dotted line, right, like, it means like it doesn't constitute a lot of importance. Sorry, it doesn't constitute a lot of importance, and those vectors you will just remove it. Okay, like you will put it as 0 in that case, and that step is known as trim. And then the next step you will do is elect sign. Okay, there is a problem which was there with previous merging method, which was just to do average. Okay, let's say you have 3 models. What you will do is, you will average all of those vectors, and that will give you a new vector. Okay, that is how it happened. But what happened was, when there is a conflict in sign, right? For example, here, when there is a conflict of sign, it failed. For example, there is a model 1 which is going up, and model 2 is also going up. Mean will also do good, ties also will do good. Okay, when the model 1 is slightly lesser, and model 1 is like constituting very less information, okay, and model 2 is constituting very good information, ties will give very good result, but mean will lessen the result. Okay, but when you have opposite, right, you can see here the difference is pretty high, right? Like when you do average of a negative and positive, always you are going to get very less performance, and that is what elect sign does. So let's say I have 3 models, and 2 models are saying positive and 1 model is saying negative. I'll not even consider the negative for the 2 model as positive. I'll see if it is constituting well, and if those 2 are constituting well, I'll just average both. And if only one is doing well and other is not doing well, I'll trim it, and the only one will be considered. That is how the sign conflict will be resolved, and then we have a disjoint merge. As you can see here the pink one is removed, here also the pink one is removed, and these 2 are averaged. Okay, so that is how ties method work, and let me go you through with the content specified in this block. So here it is said that they have redundancy in model parameters, and disagreement between parameter signs has been the challenge, which I said right now, and they solved it with the help of 3 steps, which is trim, elect sign, and disjoint merge. Okay, which we also saw right now. And this is the configuration for you to combine the model with ties method. And next is dar method, which is a similar approach to ties, but what happens is there we just see how much it is important, and based on that we'll either trim or we'll resolve the conflict, right? Sign conflict. But here we'll also randomly reset the fine-tuned weights into its original value so that it is very stable. Okay, so that is what pruning does in dar. And rescaling is to make the fact that your base model always keeps its expectations being solved. Okay, let's say I'm expecting a model to say I am good, and I'm combining 2 to 3 models. I don't want it to like generate some other word instead of good, right? It is very problematic in risky scenario probably, or a highly sensitive scenario. Yeah, I was just searching for the name. In a risky or high sensitive scenario, even a word change might give a lot of issues, which can be solved a bit with the help of rescaling. Okay, and for dar itself they would have given 2 methods, which is dar ties and dar linear. Okay, and then finally we have Frankenstein method or Franken merges method, which is also known as pass through. It's nothing but like you'll have 2 models one after another. So let's say you have 2 models, Mistral itself. One is 32 layer, and then another one also it is 32 layer. If you stack one after another, it will become 64 layer. Okay, one model of 64 layer. But if you stack, like, you can also do specific layers. Okay, let's say you have first 16 layers from Mistral 1 and second 16 layer from Mistral 2, it will become 32 layers itself. So this is not much of, how can I say, very good method, because you are gonna lose on computation. But if you can find the right merge, this can also be very helpful. So yeah, that is about the methods in which you can merge. Now let's see a practical implementation for these methods. Okay, so first let me go through the notebook I created, or probably I used to create the best model, and I'll also say you how you can tweak it for your other methods. Okay, so the first thing you want to do is, I'll give you the notebook in GitHub, so you can just download it. I prefer you to use Collab itself. If you have good GPUs, go on, feel free to use it in local itself, but if you don't have good GPUs, I recommend you to use Google Colab. And guys, as a bonus, I have attached a section on MOE. Okay, you can also create a MOE with the help of this library itself without even training it. I'll also say how you can do that at the end of this video, so please stay till the end. Here, if you see, we have the model name to be Beast Soul New. Okay, and that is the model name I have given. I love the name Beast Soul, so I have given Beast Soul New. You can give your own name, and then we need to provide a YAML config. Okay, so in that you'll have the first key named as sources. Okay, so what are the models for your merge source? You're gonna merge and you need some source models for you to merge, right? What are those models? For now, here I'm considering 2 models, which is UD Chi 3rd, which is my base model. Okay, let me put that here, and also I'll also show you how you can upload your model into Leaderboard so that you can see how good you're performing, and probably even let me know how you performed, and then I'll probably follow the same merge for myself. Okay, so I recommend you all to follow this video completely and upload your models to Leaderboard and let me know if you can get a better performance than what I have right now. So this is the first model which I'm considering to be my base model. When I did this, this was a pretty good model. It was one of the top models, so I considered this because it was giving pretty good results at that time itself. Okay, and then on top of that I merged another model known as Flemingale. I guess I spelled it correctly. Fleming-Miguel MBX7B. This is the second model I merged. So you can also use these two models for your merging, and the merge method I used was slurp because that is the most famous method. But yeah, like I said, I'll also show you how you can do for other methods. Next we have a parameter for us to state that this is the base model. Okay, because I'm saying, okay, I want to merge Fleming-Miguel MBX7B to UDK THRDS. Okay, not the other way around. So that is my base model, and I'm stating that the parameters are I wanna give this much importance to attention and this much importance to each at multi-layer perceptron. Okay, I'll recommend you all to keep this as the same because it works very well. And I'm stating that I want the data type to be bfloat16. Okay, now coming on to the merge, you don't even need to edit anything here. What you all need to do is change your runtime here. I ran it in CPU, it worked, so probably it should work for you as well. But if you are going for other models, please check if it is loadable in CPU. So in that, what it does is basically it will try to clone the Mergekit. GitHub repository, and then it will create a YAML config based on the config we wrote here, and then it will call this specific CLI command known as mergekit YAML config.yaml merge models, and I'll also copy the tokenizer. Here since I'm running in CPU, it will also use lazy tensor loader, and then it will make sure that each shard size is 1 byte. Okay, so yeah, that is about the merge. And then you need to put your secret key here. Okay, I hope you all know how to create a Hugging Face token. Once that is done, click add new secret. For that you need to do is click this key button, put your token name here, put your value here, click access. That's all, you are done. And then you need to put that name in here in token. Okay, if you do that and put your username here and a license here, you'll be pretty much sorted. Okay, you can just run this and it will run it. So that is about the merging. Okay, but like I said, what you need to do for other methods and what you need to do for OpenLLM Leaderboard. So the first thing is, they have given this configuration, right? All you need to do is copy this, paste it in here. Okay, just paste it in here, replace with your models, and you are done. You can just choose any model, but the base architecture should be same. For example, all these models are of the same architecture, Mistral. Okay, even these two are Mistral. So if you are gonna merge llama type models, use llama type models. If you're gonna use phi model, then use phi type of models. Okay, the base model should be the same, and the parameters also should be the same. Like if you are merging 7 billion model, it should be 7 billion models. Okay, those are some restrictions for you to do when you are merging models. Okay, now let's say you have completed it, your model is uploaded. Okay, so now what you need to do is to do leaderboard, right? You need to go to Huggingface Open LLM Leaderboard. You can see here there's a button on a submit here, and then you need to fill out your model name here, which you can copy from Hugging Face itself. For example, if let's say Mistral 8B instruct v0.1 is my model, I can just paste it here. Okay, and then specify your model type. For example, right now we are just doing merges and merges. Why it is known as merges, that is what we are going to see in the second half of this video. Okay, you can just click this and click your precision to be bfloat16, and that's it. If you click submit, well, at some time it might ask your license. Okay, it may ask you to add license to your model. So at the time, what you need to do is, here, for example, my model is Vasant Beast Soul. Okay, as you can see here, this was my old merge. It didn't give as good as the result which is there right now, but people have downloaded my model, like it's around 921. So yeah, what you need to do is, you can click this model card and then click edit. Okay, if you get that error, it is saying like license is not there, you need to add your license here. Like for example, I can just add it here. Okay, like this. If you do that and click commit here, obviously I didn't change anything. For you it might change, so then you need to click commit changes to main, and then what you need to do is reload the Huggingface Open LLM leaderboard, fill out the form again, and then leave it for 1 or 2 hours, and then you can search your model in there and it will work. And if it doesn't work and your model is ready, let me know in the comment section, or even you can ping me in the Telegram group. I'll help you out to find your model in the leaderboard.
So we have seen how to merge the model, but there might be a thought for you all. Okay, we have merged it, but it doesn't solve my use case, right? Something like that. See, in that case, what you can do is, if this doesn't solve your use case problems, take this model, but the merge should be appropriate. Okay, let's say I'm building a model which can help me with math queries. Okay, a chatbot which can help my use case where it should answer some math queries. Okay, then what you need to do is merge a model with math knowledge with the chat model. Okay, consider that way. But if you think the result is not suffice enough, then what you need to do is, in our channel itself I have covered about this method. It is known as direct preference optimization. Let me put it as our channel name itself. I have covered a video about this, and I have made both theory and practical implementation about all of these. Okay, here you can see for Mistral I have made this. Okay, so what you can do is, this is 7 billion and it is executed in Google Colab itself. So still we are building our best model possible with Google Colab itself. If you complete doing DPO, then surely it is going to be your best model.
Okay, now that the merging is done, let me say what you need to do if you want to do MOE. Okay, for MOE, what you need to do is, first thing, you need to provide your base model. Just you guys need to understand that this guy Maxim Labon, he created his own like adaptation for phi. Okay, but you can't do that right now. So what you need to do is find 2 to 3 mixtural models. Let's say you're finding these two itself. Just put these here. Okay, put one of these model in base model. Let's say I'm doing it right now. Okay, I'm not gonna run it, but you can run it also, because I don't think I have space. But if you have good GPUs, you can also try to use this. But I'm saying, guys, this is the best model I have right now, and I'm not even putting hard efforts to it by fine-tuning it or something like that. Okay, let's say I'm just merging 2 of these. Okay, all you need to do is, you want to say which model you're gonna use for which task. Let's say Turdus is good with math, and Fleming Miguel is good with probably poetry. I'm gonna ask some questions related to poetry in this positive prompts. Let's say it is, what is poetry, something like that. But with Turdus, let's say I'll be asking, what is 2 plus 2? And all you need to do is replace this config with this. That is the first step. And then the next step is click mixtural branch. Okay, and enable load in 4-bit here. Okay, load in 4-bit. Okay, and with these two you would be sorted. All right, I'm not gonna change this. I'm gonna keep it the way it was, so that you guys can execute how I have right now. Okay, but you can change this to do MOE merge. So basically what happens in this MOE merge is that they are trying to replicate the functionality of mixture of expert gate. Okay, the gate network, the idea of gate network in short is that you wanna say that this specific token, it is more suited to be answered by the model A rather than model B. That decision is to be decided by gate network, and here they do it with the help of some semantic similarity, and that is why they are asking you some prompts for them to check. Okay, this is closer to this. Okay, so you can say that this is a clown MOE, and that is how the author Charles Goddard has termed this MOERCH. Okay, and the other process will remain the same. Okay, once the model is ready, you can just again run this cell and run this cell again, and then yeah, you are good to go to push it to the hub. Okay, and yeah guys, that is for this video, where in this video I've shown you how I've created my current best model, and you can see it is one of the top 50 models in the Open LLM leaderboard. Okay, so in the next video I'll see you with an amazing idea where I've created a WhatsApp chatbot. I'll show you a demo right now. So yeah guys, this is my WhatsApp bot where I have connected an LLM with the help of Twilio to my WhatsApp, where I can ask questions and it will answer. In the next video I'll show you how you can all create this kind of a bot with your own LLM. I'll see you all in the next video guys. Until then, if you haven't liked this video, please hit the like button and share it with your friends. And if you haven't subscribed to the channel, please subscribe, because there are lots of quizzes going, and if you want to win, to get notified at least, you want to be subscribed, and share it with your friends if you think they might find this helpful. I'll see you all in the next video guys. Until then, cheers.